Sketch the root locus of the system whose transfer function is given by g of s is equal to k by s into s plus 2 into s plus 4. So, here as we already said, the first step is to find the open loop poles and find the poles and zeros. Poles and zeros. Okay. So, g of s is equal to given this. Okay. Now, what are the poles? Poles are obtained by equating the denominator to 0, that is s into s plus 2 into s plus 4 is equal to 0 implies s is equal to 0, minus 2 and minus 4. Okay. So, here these are the poles and zeros are obtained by equating the numerator to 0. So, here there is no s term, hence there will not be any number of zeros. So, number of poles is equal to 3 and number of zeros is equal to 0. Okay. So, this is the first step. Now, step 2. Step 2 is find the centroid. Find the centroid. Okay. So, centroid is given by the equation summation of poles minus summation of zeros divided by number of poles minus number of zeros. Already we have discussed, and summation of poles means 0 minus 2 minus 4. Okay. Those are the poles and there is no 0, so I have given 0, and p minus 0, number of poles minus 0, that is 3 minus 0, which is equal to minus 6 by 3, okay, which is equal to minus 2. So, step 2, we have found the centroid as minus 2. Now, step 3. Step 3 is find the angle of asymptotes. Find the angle of asymptotes. Okay. So, here there are 3 poles, hence the total number of branches of root locus is equal to 3. Total number of branches of root locus is equal to 3, and the angle of asymptotes is given by the equation theta is equal to 2q plus 1 into 180 divided by p minus z, and we have already seen that p minus z is equal to 3. Okay. So, 2q plus 1 into 180 by p minus z is equal to 3. 180 by 3 is 60. Okay. This is equal to 2q plus 1 into 60. Okay. So, it will be the odd multiple. Okay. So, theta 1 is equal to 1 into, so it is 3, hence 3 multiples will come, 1 into 60 which is equal to 60 degree, theta 2 is equal to 2 into 60 which is equal to 3 into 60 which is equal to 180 degree, and theta 3 is equal to 5 into 60 which is equal to 300 degree. So, angles of asymptotes are odd multiple of 180 by p minus z, odd multiple. Here 3 p minus z is equal to 3, hence we have 3 asymptotes. Okay. So, it will be 1 into 60, 3 into 60 and 5 into 60. We have already discussed it in the step by step procedure. Okay. Now, next step is step 4 is find the root locus. Okay. So, here we have to plot the pole 0 plot, that is, it is the real axis and it is the imaginary axis, or sigma and j omega, that is the s axis. Okay. For plotting the root locus, we have 3 poles, that is at s is equal to 0, -2 and -4. So, poles are denoted by cross mark and zeros are denoted by, poles are denoted by cross mark and zeros are denoted by 0. Okay, in the pole 0 plot. So, here we have only poles, hence s is equal to 0, s is equal to -2 and at s is equal to -4. Okay, I have roughly drawn it. Now, I have 3 parts in the 4 parts in the real axis, part 1, part 2, part 3 and part 4. Take one point here and look to the right if there are odd number of poles and zeros, then in the real axis, then there will be the root locus. So, in this part there will be no root locus. So, here if I take a point here and check to the right side, then I have one pole, that is odd number of poles, hence root locus lie in this region. Okay, root locus lie in this region and it will be moving like this towards each other. Okay, so it will be moving towards each other. Now, and it will meet at a point and it will goes to infinity. Okay, break from this point and goes to infinity, that is called the breakaway point. Okay, between 2 poles, both the poles move towards each other and it will go break from that point towards the infinity. Okay, if I take a point here, then there are even number of poles, hence the root locus does not lie in this point. And if I take a point here between infinity and 4, then there are 1, 2 and 3 odd number of poles and zeros, hence the root locus can lie in this part also and it will be moving towards infinity. Okay. So, I can have the root locus here and also I have the root locus in this portion. Okay. Now, in step 3 I have found, step 2 I have found the centroid as -2. Okay. So, the centroid is -2 and I have found the angle of asymptotes. Okay, angle of asymptotes 60, 180 and 300. So, this is 60. Okay, I have roughly drawing it. This is 60 theta 1 and this is 300. Okay, 300 degree. This is 300 degree and this is 60 degree, or you can write plus 60 and minus 60. Okay. So, at this point is the centroid and my asymptotes will be at an angle 60 degree and 300 degree and 180 degree. Okay, 180 degree I have one asymptote, already one root locus in the 180 degree. So, it denotes that. Okay. Now, step 5. Step 5 is to find the breakaway point. Okay, here there is no zeros, hence there is no break-in point. So here step 5 is to find the breakaway point. Okay, to find the breakaway point we have to, we know the closed loop transfer function is g of s by 1 plus g of s h of s, and this 1 plus g of s h of s is called the characteristic equation. So the characteristic equation is 1 plus g of s h of s is equal to 0. Okay, so that means c of s by r of s is equal to, given g of s is equal to k by s into s plus 2 into s plus 4 by 1 plus s into s 1 by k by 1 plus k by s into s plus 2 into s plus 3, and we have given it as unity feedback system, then h of s is equal to 1, okay, into 1 is equal to, so this is c of s r of s, so this is 1 plus g of s h of s. So characteristic equation is 1 plus k by s into s plus 2 into s of plus 3 is equal to 0, implies that s into s plus 2 into s plus 4, sorry, s plus 4 plus k is equal to 0. Okay, or we will get s cube plus 6s square plus 8s plus k is equal to 0. So this is the characteristic equation. Okay, this is the characteristic equation, and from here I will get k is equal to minus of s cube plus 6s square plus 8s plus 8s. Okay, from this I will get the value of k. Okay, so now find dk by ds. Okay, find dk by ds, find the characteristic equation and find dk by ds. Okay, dk by ds is equal to minus of 3s square plus 12s plus 8 and equate it to 0. Okay, and this implies 3s square plus 12s plus 8 is equal to 0, and solving it, solving the equation, okay, we get s is equal to minus 0.845 or minus 3.154. Okay, so what have we done? To find the breakaway point, find the characteristic equation and equate it to 0. Okay, and from it find the value of k, and then find dk by ds and equate it to 0. Then solve the equation and find the values of s. Now substitute this s in this k. Okay, so checking for k, okay, substitute the values of s is equal to minus 0.845 and minus 3.154. For s is equal to minus 0.845, the value of k is 3.08. Okay, substitute it and find the value of k. And for s is equal to minus 3.154, the value of k is minus 3.08. Okay, so here it is negative, hence it is not the breakaway point. okay, but here it is positive, hence it is the breakaway point. So the breakaway point is K is equal to minus 0.845. Okay, so this is how we are finding the breakaway point. Now the next step is, okay, once we have found the breakaway point, so the breakaway point we have to find the value of S and check for K. Okay, substitute in this K value, substitute the S value in this K value and find the value of K. If it is positive, then that will be the breakaway point. If we get both as positive, then both will be the breakaway point. Okay, so now here it is, one is positive and one is negative, hence since it is negative it cannot be the breakaway point. So this S value will be the breakaway point. Okay, now step 6 is find the crossover point. Okay, so here we are using the root array method and we have the characteristic equation. Equation we have marked it as 1. So this S cube plus 6S square plus 8S plus K is equal to 0. Okay, and obtain the root array. Okay, how we are forming the root array? We have S cube, S square, S and S raised to 0. Okay, these three terms, and S cube term is 1 and S term is 8. S square term is 6 and S raised to 0 is K. Okay, now the next line will be 6 into 8. Okay, 6 into 8 minus 1 into K divided by 6. Okay, that is 48 minus K by 6. Okay, that is this value, and here we will be having K. Okay, 48 minus K by 6, that is the S value. Okay, take this and equate to 0. Okay, from here we will get the K is equal to 48. Okay, you get the value of K as 48. Then also note this S square term. Okay, so this is the basic method, that is there will be a K term and that K term should be equated to 0 and you should find the K value, and also find the S square term, that is 6S square plus K is equal to 0. From here we will get S square 6S square plus 48. Substitute this here, 48 is equal to 0. Then you will get S square is equal to minus 8, or S is equal to plus or minus J root 8, that is plus or minus J 2.8. So this is the crossover point. Okay, so take this S square term where K is there and equate it to 0. Substitute the value of K which we have found here. Then from that find the S. Okay. Now step 7 is find the angle of departure and angle of arrival. Okay, here there is no complex poles. Okay, the poles are 0, -2 and 4. since there are no complex poles, we don't have to find the angle of departure and angle of arrival. So now step 8 is sketch the root locus. Okay, so I am roughly sketching it. So I have s is equal to 0, s is equal to minus 2 and s is equal to minus 4, and the root locus lie this part and this part. Okay, so it will be moving towards each other and here it will be moving towards infinity. Okay, now at the point minus 0.8 both the root locus will meet. Okay, minus 0.8. So we have found the S value here, minus 0.845. So that is minus 0.85. Okay, marking it as this minus 0.85. The root locus will meet and it will move away. Okay, so and we have found this as the centroid. Centroid is minus 2 and we have noted the angle of asymptotes. Okay, this already we have note. And now at plus or minus j 2.8. Okay, j 2.8 and minus j 2.8, the asymptotes will cross the root locus will cross the imaginary axis. Okay, so the root locus will travel towards this way and it will travel parallel to the asymptotes. Okay, so it will move like this and it will meet at infinity. Okay, this is the rough sketch and we can draw it in the graph paper. Okay, this is the rough sketch where from the breakaway point, at the breakaway point the two poles will travel, the root locus will travel towards each other and meet and will break. Okay, break, one path will move through the parallel to one of the asymptote and the other will move parallel to the other asymptote and it will cross the imaginary axis at j 2.8 and minus j 2.8. So at this point it will cross the imaginary axis and it will travel parallel to the asymptotes. Okay, this is how we are sketching the root locus.